Okay, so the topic of today is method of concurrent deviations. Now this is the last one as far as correlation chapter is concerned. Method of concurrent deviations is denoted by RC, and we are taking up this example whereby two series are given, and now you have to calculate the coefficient of correlation by using method of concurrent deviations. Now see how you are going to calculate it. First of all, we will be constructing a column for deviation sign of X series. Then we will be constructing another column for deviation signs of Y series. So we will be constructing a column for deviation signs of X series and deviation signs of Y series. After that, the last one is concurrent deviations. Now how you are going to derive it? See, deviation signs of X series. In order to calculate deviation signs, we need to compare a number with a number which is above it. Now there isn't any number above 320, so the first space is always left blank. Now this number 310 is less than 320. So when a number is less than its above place number, you will have to place a negative sign, and in case if the number is greater than its above number's place, then you will have to place a positive sign. If a number is less, then you will have to place a negative sign, and if a number is greater than its above value, you will have to place a positive sign. So in this case, we just need to give positive as well as negative signs. Now 310 is exactly equal to its above placed number, that is 310. So when the numbers are equal, we need to place an equality sign. 294 is less than 310, so there will be a negative sign. 282, it is also less than 294, so there will be a negative sign. 270 is also less than 282, again a negative symbol. 240 is also less than 270, again there will be a negative sign. 212 is also less than 240, there will be a negative sign. But 245 is greater than 212, so now there will be a positive sign. 300 is greater than 245, again there will be a positive sign. 364 is greater than 300, so there will be a positive sign. And finally 336 is less than 364, so there will be a negative sign. So if a number is greater, you will have to assign a positive sign, while if the number is less than the above number, you will have to place a negative sign. Similarly, the same course of action will follow in Y series. Since there isn't any number above the first place number, so the first space will be left blank. Now 24 is less than 22 is less than 24, so there will be a negative sign. 20 is less than 22, again a negative sign. 16 is less than 20, negative sign. 15 is less than 16, again a negative symbol. 13 is less than 15, again a negative symbol. 12 is less than 13, again a negative sign. This 12 is exactly equal to its above number, so there will be an equality sign. 16 is greater than 12, it will be a positive. 22 is greater than 16, again a positive. 27 is greater than 22, positive value. And 24 is less than 27, so this is a negative valued place. So we have assigned the negative signs. Now concurrent deviations will be calculated by multiplying the deviation signs of X and Y series. So multiply both the signs, minus minus will give you plus, equal minus will give you minus, minus minus will be plus, minus minus will again be plus, minus minus, again plus, minus minus, again plus, but minus equal will be equal to negative sign, plus plus will be plus, positive positive will again make positive, positive positive will be positive, and minus minus will be equal to positive. So now you count the number of positive signs. All these number of positive signs will be denoted by small c over here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the value of c will be equal to 9. C over here denotes the number of positive signs. So number of positive signs are denoted by C, and now we are going to place this in our formula, that is 2 into C minus n upon n. Take down the formula. 2 into C. We have just calculated the value of C, and C was equal to 9. Now n over here stands for number of pair of observations compared. Number of pair of observations compared denotes, the number of times you have made comparisons, and obviously you have left, the first place blank. So this value will be ignored while calculating n. So the number of comparisons made were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there were all in all 11 times the comparisons were made. So number of pair of observations compared are equal to 11. Now we need to solve it. 2 9s are 18 minus 11 upon 11. So that will be equal to 7 upon 11 square root. So the square root of, first of all, divide 7 upon 11 and just do the square root of it. That will be equal to
0.797.
0.797. So this will be the value of coefficient of correlation by applying method of concurrent deviation. So is this method clear to everyone? Method of concurrent deviations.